Thank you everyone on my Zoom screen for coming to the Leap Wallerstein panel series on AI and extreme weather preparedness session on AI for wildfires and heat waves. So if this is your first time coming, my name is Geneva List. I'm a senior staff researcher at the Columbia University Climate School, and I work at LEAP, the Center for Learning the Earth with Artificial Intelligence and Physics. I have been moderating and curating this series. Um, oh, Jet 10? Okay, Jet 10's okay. I thought. This is the fourth session of our panel series, which aims to provide a platform for interdisciplinary experts conducting applied research, interdisciplinary experts and dialogues to have a knowledge exchange between academia and the broader climate resilience and disaster community on the suite of AI and machine learning applications to help enable extreme weather preparedness. Today, I am particularly excited to bring together our interdisciplinary experts who are conducting applied research and developing decision support tools to help predict and mitigate wildfire and heat wave risk. So before I begin with the introductions and bios, I actually wanted to take a second just to set the stage today. So we are, again, predicted to have an above normal wildfire season in the US. And as a Canadian, this really hits home, having witnessed the mass destruction of the Jasper National Park last year and having watched the LA wildfires this year. So I just want to set this as setting the stage. I'm hopeful that we can use the emerging technologies to improve our risk mitigation measures, and also more broadly to leverage these new technologies to mitigate the drivers of this risk. So to begin, I will introduce our panelists. And I have the pleasure to introduce Ali Ahmadalipour. Dr. Ali Ahmadalipour is a research scientist at Bellwether, a Google X Moonshot factory project where his focus lies in the realms of geospatial AI and climate extremes. In 2017, he earned his PhD specializing in hydroclimatology and risk assessment. He then worked at a couple of startups at the intersection of AI, agriculture, insurance, and climate. Since 2022, Ali has been working at Google X, making strides in the research and development efforts to tackle large-scale geospatial ML challenges. Beyond his work, Ali can be your go-to friend in the geospatial community. He runs the Geospatial Jobs and Geo AI Unpacked newsletters, where he shares tech jobs and industry updates with thousands of climate tech followers. So welcome. Thank you, Ali. The next panelist is Elena Zoplacki. Dr. Elena Zoplacki is acting head of climatology, climate dynamics, and climate change group at the Department of Geography in the Justus Liebig University, pardon my pronunciations, Gießen, Germany. She holds a PhD in climate science, natural sciences, from the Faculty of Sciences in the University of Bern, Switzerland. She's an expert in climate change in the Mediterranean region and conducts research on weather extremes such as heat waves, floods, and droughts, as well as compound and concurrent events, paleoclimatology, climate reconstructions and model comparison, the influence of atmospheric circulation on European and Mediterranean climate, and the associated health effects. Dr. Zoplacki teaches both the Bachelor's of Science and Master of Science levels and has participated in and coordinated numerous research projects funded by European, Swiss, German, and US institutions. She is the principal investigator for the ERC Synergy Project, Europest, and serves as co-chair of the International Telecommunications Union, World Meteorological Organization, and United Nations Environment Program focus group on AI for natural disaster management, which recently transitioned to the Global Initiative on Resilience to Natural Hazards through AI Solutions. So we are so excited to have you here. I'm also a fellow geographer, so I resonate with both Ali and Elena's work. Our next panelist is Jorge Perez Aracil. He is an assistant professor at the University of Alcalá, specializing in optimization, machine learning, and deep learning. He holds a PhD in civil engineering from the University of Exeter and has received several grants to support his research. His research achievements have been recognized with several awards, including the Best Young Researcher Award from the University of Alcalá. Congratulations. And he actively collaborates with international research groups, including the International Telecommunications Union, AI for Natural Hazards Initiative, as we just mentioned, and is currently working on the European project CLINT, which he will introduce us to today. He's also developing code for detecting and predicting extreme events, and has extensive experience in applying AI to environmental challenges. Thank you, Jorge. And last but not least, we have Jatan Buch. Dr. Jatan Buch is a postdoctoral researcher in the Department of Earth and Environmental Engineering at Columbia University, studying wildfires, air quality, and multi-scale aerosol cloud interactions with physics-informed machine learning. He is also the lead developer of a stochastic machine learning model, SLM-FIRE 1.0, for forecasting wildfire activity in the Western United States on subseasonal to seasonal timescales. Before transitioning to climate science, he completed a physics PhD at Brown University, where he searched for signatures of particle dark matter in data from terrestrial experiments and astrophysical sources. So fantastic. We have such an incredible set of panelists here today with varied experience, and I am so excited to be able to take just the next hour to learn from all of you. So thank you again so much for being here. We're going to start right off with introducing our panelists' work on wildfires and heat wave predictions. So I have asked our four panelists to identify how they're using machine learning or AI to improve the climate science and prediction of extreme weather events, as well as what the improvements AI has enabled. And I've asked them to take this opportunity to identify the various data sources they're using. So I will begin with Jatan and then Jorge, who will I will have some background slides to share along with their presentations, and then we'll move to Elena and Ali, who can discuss some of the decision support tools related to these hazards. So welcome, and I hope you're all going to enjoy the next hour of discussion. Jatan, please feel free to introduce your work.
Thank you, Geneva, for the very kind introduction, and I'm excited to be on this great panel and looking forward to the discussion. This is going to be very short. I'm going to highlight two papers that are a LEAP production. So this is playing to the home crowd. One of which I led, which is a stochastic machine learning model. It's SMELL-FIRE, and there's a follow-up work that is in the pipeline called Ceasefire, where machine learning is basically being used to track all the drivers of fire. So fire has four main drivers. There's climate, there's topography, there's vegetation, and there's, of course, sources of ignition, right? And these can be human, or this can be natural. And the idea is, how can we systematically integrate the different patterns of fires that happen across the Western United States, stretching all the way from the wetter regions of the Pacific Northwest to the very arid regions of the Southwest. How can we integrate this all in one box, so to speak? And machine learning offers a very promising way to do this. And the details are available in this paper, but I wanted to highlight two plots where this model was able to reproduce both the monthly and the annual fire frequency, as well as the annual area burn, monthly and annual area burn across the Western US, but also do this at the grid scale level in 12 kilometer by 12 kilometer grid cells in the Western US. So I'm only showing in these panels the total aggregate results. From a human perspective, though, I think this leads me to the second work, which is sure, fires actually destroy property, they damage ecosystems, and often also affect stream flow. But as humans, the way we interact with fires most commonly is through perturbations to air quality. And the way we simulate this is using expensive numerical weather prediction models. However, it turns out that these are extremely computationally expensive to run in real time, and so instead we use this graph neural network approach. And so this was work done with Kara Lamb and Pierre Gentin, both at LEAP, but it was led by this awesome summer student we had, Kailin Liao. And here we apply this graph neural network approach in parts of California to simulate the PM 2.5 concentration from prescribed fires. And again, the link of the paper is here, and I'm happy to chat more in the discussion section.
Fantastic. Thank you so much. Jorge, let's move to you.
Hi, everyone. Thank you, Geneva. I'm very excited to be here, so I'm very acknowledged for the invitation. So I'm going to introduce briefly what is CLINT. CLINT is a horizontal European project that aims to improve the detection, prediction, and attribution of different extreme events, such as heat waves, droughts, and tropical cyclones. So we are using different databases, as we are going to discuss later maybe, and the different groups are working together for improving the climate services by using AI-based algorithms. So in our case, in the next slide, we can show that we have been working on heat waves by improving how the reconstruction of the past event can allow us to understand better introduction or better interaction with the future projection of the heat waves. And also we have developed several algorithms that allow us to study or to understand how the anthropogenic effect is influencing the occurrence and also the intensity of these heat waves. And also in the next slide, we can show how we have developed different frameworks that allow to identify and to understand what are the most important drivers of the different extreme events by reducing the dimensionality reduction and also the temporal resolution. So this is just some application we have developed in the CLINT project, but we have also applied these techniques for the different extreme events, as I mentioned, in the droughts and tropical cyclone, and they can be used as well for the other type of applications like wildfires or other type of events. And yeah.
Brilliant. Thank you so much.
Thank you.
Great. Elena, please kindly introduce your work.
Yeah, thank you very much. So I don't have slides to share, but I do have, let me see. Can you see my screen?
Not yet. Oh, yes, slowly.
It comes, right?
It is here. Yeah, thank you.
Okay, wonderful. So actually, I would like to talk to you about the MedEWSA Horizon Europe project, which is developing a scalable early warning system for the Euro-Mediterranean and African region. The idea behind is to build on existing tools, and that at national and regional levels, and use AI and machine learning to introduce a standardized decision support system. And that would be for a decision supports dissemination system for risk and vulnerability assessment. So actually, what we would like to do is to take advantage of what is already there. So existing capabilities, enhance them into a fully integrated multi-hazard platform that is covering actually the overall early warning value chain. And this value chain, what we are interested in is to address from end users, that is first responders, planners, up to ministries, and the whole value chain. We are tackling the challenges actually of loss and damage from extreme events and natural hazards. And what the project is aiming at is, let me go a bit to the, objectives, is to is aiming to offer multi-hazard capacity building for responders, timely handling of cascading effects, and that would be actually an efficient response mechanism to extreme events. We aim to have a full coverage of the early warning cycle, meaning from data to public safety, enhancing resilience and reducing the impact of an area. Remember, it's a Euro-Mediterranean, Northern African area, highly populated, very economically vital, and rapidly warming, together with a very high diversity in the people and the hazards that are experienced in these areas. An example would be something like the year 2018, where at least across much of Europe, we have faced unprecedented sequence of compound events. So actually, we had impacts on human lives, ecosystems, as well as infrastructure. We saw extreme heat and one of the longest droughts since 1500. We saw, and that is actually what we would like to do to address these types of events, and that for the use case areas in the research region, such as concurrent extremes, as what we had in 2018, which is actually events that are simply taking place close in time, either in the same time or with a time lag among them for the different areas. So what we're trying to do here is, here you can see one of our sites is to take advantage of existing methods and enhance them with machine learning in order to identify, to enable best decision making using AI in order to calculate, for example, processes that are defining the dependencies on among these different types of events. What we're aiming to do as well is to work also not only on recent past, but to work also on different temporal horizons into the future. That would be from short-term to sub-seasonal and seasonal forecasts, and looking at different types of extreme events that are affecting the areas we are working on. And with that, I would like to thank you very much, and looking forward to the discussion.
Fantastic, thank you. And Ali, please introduce your work and Bellwether.
Yeah, thanks so much. Really glad to be here. And I don't have the slides either. I just shared 2 links that basically gives a gist of what we do. So I work at this team called Bellwether, which is an X Moonshot factory, and X is basically a part of Alphabet. So long story short, what we do, we have 2 main product lines. One is a post-disaster recovery tool that's focused on basically image geolocalization. So what happens in the US and in many other places in the world. So for instance, in the US, there's civil air patrol after major extreme events like floods or wildfires or tornadoes. This team flies airplanes and takes photos from the airplane with any kind of camera. And what we do is basically we develop this machine learning algorithm that takes the data and all those images and identifies critical infrastructure in those images. Basically geolocates the image and says if there's a hospital in this image, or a let's say school in this image, or transmission line or things like that. And that's very useful for disaster recovery and also evacuations and things like that. That's mainly government focused. And the second product line that we have is the second product line that we have is the wildfire risk forecasting which is basically a data-driven approach that takes a ton of data, geospatial, environmental, climate, and other sorts of data, and then forecasts wildfire risk 1 year or 5 years into the future. And that's at 100-meter resolution across the US, Canada, Australia. And basically, that's one important distinction that we should focus on is basically it's not wildfire prediction, so to say. It's a forecast, longer-term probabilistic forecast of wildfire occurrence. And then there's a whole suite of tools and models that basically go into different applications and different characteristics of wildfire and their losses. And the distinction between forecast and prediction, I think everyone should kind of pay attention to that, is from the book Nate Silver had, Signal and Noise, which is a great read if you haven't read it. Yeah, thank you.
Fantastic. Thank you so much. I'm happy that you raised that distinction because timescales are so important when we're talking about preparedness and resilience. Excellent. So now I'd really love to spend some time digging into the process of bringing together cutting edge research for actionable solutions. So I'll come back to first Ali and Elena again, and I'd love to hear how you get from AI enhanced science and research on extreme weather to the process of developing something that can be used for decision support. And as you reflect on this, I'd love to know what have been some of the biggest or unexpected challenges in making the science and data more usable for decision makers. And if you could let me know a little bit about who is currently or who is planning to be the main users of this data and these tools, and in what ways they might use them. So Elena, perhaps I can start with you to hear about this process of bringing research to action. Thank you.
Yes, thank you very much. Actually, yes, this is a very good question. And it's, especially for us, it has not been a very easy way because as I said already before, we are talking about an area which is highly diverse, which has is expecting has different challenges to deal with, different mentalities, different capacities, capabilities, and still all these people who are there do face the same problems. So what we have done, how to bridge actually, okay, the different types of so the technology that we're using to detect and predict and see the impacts of events, because this is actually the idea behind, is to start from the end users. How to do that? We went through. We started up actually with a long surveying approach, reaching out to everyone who might be interested in receiving this type of information. So we're talking about the preparation of an early warning system that is preparing not only types of events, but also the impacts of events. So this means that as we were also trying to cover a larger range, a broad range of end users, then we were extremely active in all 8 sites that are currently in the project, receive the information, what do they have at hand, what do they need, what would they like to have. So actually trying to monitor the wishes and the needs of our end users. And there we also introduced at the same time what is that we would like to do, how can we take the output, which is expected to be, and this is actually our big promise, that we are enhancing accuracy, we are enhancing the capacity of these models to provide better actionable results. So making our results directly going to the end users, mobilizing first responders. That was actually what made us more and remain in continuous interaction with our end users. At the same time, we have a very large consortium, larger than fact for the size of a project, where stakeholders and users are already in the consortium. So we go with this to be very trendy wording of co-design, co-creation, but this is actually what is required. We're talking about people and impacts and what is affecting them. Challenges, yes, very different types of data, availabilities, qualities, resolutions, and then very different types of receivers of our outputs. So there comes really humanities, social scientists who have to come into the game and try to translate what the models and the data provides to the people to make the warnings actionable. I think that's more or less.
That is fantastic, and all of this is also music to my ears. I'm really curious, just if you could quickly, because I'd love to move on to the other panelists, but is there any hesitancy in data sharing as well among your end users? Do you have issues with regard to access to like national level data?
It seemed that there was an issue coming up, but I think we went over. So we overcome this problem. Yes, it is not always easy, especially in areas where data belong to the national defense.
Understood.
Data variability belong to national defense. And you see, we are in a very challenging, very beautiful and challenging area. So trying to get the whole Mediterranean together with with a very advanced, let's say, or seem to be advanced north and all the changes in Northern Africa, the African countries. Yes, it is not very simple, but still we were quite happy and lucky to receive the data that we needed. And fortunately, there are also the global data sets that could support us in the case. So climate data are rather easy most of the time. Other types of data are difficult.
Yeah, great. Thank you so much. That was fascinating to hear. Ali, I'd love to hear about your experience in taking this research to action and the tools that you've developed through Bellwether.
So yeah, I mean, basically we have APIs for fire risk forecasting and the other tool geolocalizations that we have. So our fire risk forecasting is a operational tool that is updated every quarter and is basically showing risk forecast for next 1 year or 5 years. And in terms of the, let's say, the other use case, as I mentioned briefly, is mostly government focused. So the FEMA or NOAA people that are in the government disaster recovery sector are more interested in the geolocalization. But let's say timeline that we have for wildfire risk forecast, 1 year or 5 year, it's more suitable for the insurance sector that we've worked with and less with the real-time or near real-time or short-term predictions. So for our wildfire, we've been partnering with insurance companies, and Swiss Re is one of our largest partners in the reinsurance sector. And more recently, just I think a couple months ago or a month ago, we launched and announced this tool called geospatial reasoning, which is sort of a geo LLM, if you would call it. So basically a conversational tool that you can interact with and basically look at geospatial data in terms of, let's say, disaster recovery, weather forecasts, and things like that. And we are working on that and bringing basically pilot testers to this new tool that we're developing, and hopefully that can facilitate the use and application of these sort of forecasts in the real world, and hopefully we can expand the users and people who are working with these tools. But beyond insurance, we've also worked with forestry, timber growers, and a bunch of municipalities, utilities. So there's like a ton of different applications and users that we have worked with. For now, it's mostly focusing on insurance. Did I miss anything, or I think that's all I remember from the questions.
Yeah, I guess one question I have about that process is, how did you engage the insurance industry, Swiss Re or FEMA and NOAA? Did you have a conversation with them? What do you need? Or how did that process unfold? If you can briefly respond and reflect on that.
Yeah, definitely. So there's basically, if you've been following the insurance news in general, so there's a lot of challenges with insuring wildfire insurance in California specifically. And the problem is, the challenge is basically that historically the amount of or the extent of wildfire has been quite significantly lower than what has happened in the past 5 or 7 years since 2018. And in California, the wildfires have grown substantially. And this year, like the patterns, the regimes, and basically understanding that we had for wildfire in California specifically has changed. And then in Canada, the same thing has been happening. There's basically wildfire news from around the globe basically happening almost every year. Some place has to this year, like I think the United Kingdom has had the largest wildfire or something like that. So basically, there is this challenge that the fire regimes have changing, and it used to be a secondary peril, if you would call them, that basically insurance companies did not take much damages or like losses from the wildfire in the past, but in recent years, it's grown substantially, and they want to be able to price it reasonably and to understand the losses in advance, anticipation, and be able to insure places, because the former understanding is no longer valid, and basically they're trying to understand how much they need to charge to basically be able to sustain their business and to not basically cancel all policies at once.
Well understood. Fantastic. Great. So I'd love to hear from Jatan and Jorge reflecting on some of these responses and perhaps bringing in some of the research perspective that you identified at the beginning. What are some of the processes that researchers can undertake to increase the eventual usability of the research or data and tools that are under development? And I'm curious to hear if you've noticed in this process of your work, have there been synergies with this accessibility and usability, or have there been some frictions? Jorge, perhaps I'll start with you and then pass it to Jatan.
Yeah, sure. Thank you. Yeah, it's a tricky question because we can approach a problem from different ways. So it's like, I would say that one point could be like early stakeholder engagement. So we can involve the end users from the beginning of the project, and we can not only the users like emergency managers or urban planners or any type of a stakeholder, but also what are their necessities, like what are the type of indexes they need to measure the impact or something, because the researchers sometimes use what is in the research community, what is in the papers, but sometimes it is not aligned with what they need, or sometimes it's not exactly the number they need to put in in the real problem. And also the second point I would say is the interpretability and transparency of the machine learning models. So we need to make the models trustable to all the users and understandable to all the users, not only for experts, but also for the final user and non-expert users. And I would say also that another point could be like continuous feedback, like prototyping the models we are using, and like make something continuous in the time. Just like, okay, we propose a model, the final user or the MIDI user can interact with us about what they need, and if we are going well, or if the response we are giving to them is correct, or we are giving a response to their necessities, and also trusting the projects in a continuous way during a long time. I would say just because, for example, in CLINT, we have developed some frameworks for detecting heat waves, drivers of heat waves and droughts and tropical cyclones, etc. And now we need more time to put this framework in operational mode, and we need more time to make them more usable for the final user. So we need like long-term frameworks or working frameworks for putting all this science or this research in the operational mode. And yeah, not sure if I'm missing something, Geneva, but I think that's
No,
okay.
I think that's brilliant. Thank you so much.
Thank you.
Jatan, I'd be curious to hear about, your reflection on this bringing the science to action.
Yeah, and I feel like, there's very little I want to add, because I think the other panelists have really hit the point home. But just to sort of synthesize this and maybe add a little bit more. So I see this broadly as science connecting to action, as you framed it, Geneva, very nicely. There's three main pillars. There's the interaction with the private sector, the system that undergirds a lot of our realities. Then there's the interaction with the land managers, as Jorge outlined, which is often like the sort of the layer through which a lot of wildfire policy is implemented. And there's some like interesting feedback that happens because Ali was talking about metrics and so on, and this is something that land managers often end up using different metrics than the one that modelers use, and some of that is like like historical practice. I mean, I've reviewed some papers and I've participated in a few of these discussions where sometimes there's actually things we can sort of extract from this like knowledge that has been accumulated over like in the modern case over the past 100 years, but also in the indigenous case over like centuries, right? And so there's this sort of feedback loop where it's not so much us interacting with the manager so that we can like implement our models. Of course, that's that part too, but also like sort of learning, okay, what is missing in our models, right? And so this kind of feedback loop, I think, is critical to improving fire models. And then there's the third part, and this is the part that, unfortunately for me, this is where for me science sort of ends. But it's like raising. I mean, there's a public communication part of it, but there's nothing we can do from a modeling perspective, right? And that is raising public awareness in terms of how fire policy affects their lives. And for me, the instructive case really here, and I know there's folks on this call who are probably more familiar with this, LEAP members. But like Oregon, for instance, had commissioned a wildfire map, and part of it was, we need to assess risk as we prepare for the next few decades, where climate change will play a prominent role in terms of driving fire risk. And this was very contentious because property values were affected. And as of this month, I think this map has been repealed. And this was fairly contentious in terms of all the discussions that happened, and it sort of ended up being a place where the science was not so much part of it as the sort of implications of science. And so I just want to like also highlight this as an area where we could do better in terms of having public outreach, having panels like this where experts like share the research that we've been doing, but also I don't know if there's other strategies that we can think of, perhaps using some kind of LLM technology just to make things more accessible, and so on. So that's how I sort of view this this area of science connecting to action.
Fantastic. Yeah, thank you. That's a really critical point that you raised. And something I really liked when we had discussed initially together was you were mentioning, 50% of the effort is the science and 50% of the effort is like the decision makers. And I like that framing as well when we think about this holistically, and not to mention some of the issues we run into with politics. So I think that I see that there's a little bit of movement in the chat, but I'm not monitoring it. I'm happy to move into some audience questions. Catherine, are you able to see if there's been some questions that have not been responded to? Yeah.
I think it looks like Yuri and Elena have been having a conversation. Let me scroll back a bit to see.
Would
Nope.
either of you like to raise your question, or perhaps the dialogue, or if there's any other questions you want to bring up here? Elena, Uri, was that yeah.
Oh, no, thank you. I was just wondering if kind of MedEWSA methodology would be published and where to follow it.
Yes, of course. If I may answer also online, yes, of course. I mean, this is the idea. This is how, I mean, it's not only the new system, our output, it's always the publications as well. So this is one of the main outputs. It's a Horizon Europe project, and it's very much important that everything actually we do is not only published but also being under open science principle. So everything should be made available. And yeah, towards the a little bit later, of course, at the moment of the project.
Yeah, thank you.
Prashant, I believe you have your hand raised.
Yeah, just a very quick point. I think I agree with Jatin's point about the collaboration and the business use case. The only other thing I was going to add was sometimes there's also, even without the finished research work, there is interim results and intelligence that most probably you gain. You'd be surprised how useful that would actually be to drive business outcomes. And so that's the only other piece I would say. It's not just sort of taking a problem away and coming back with an answer, but it's really the process and the things that you most probably learn, the intelligence you learn more than the final product. I actually find that is what is missing most of the time.
Would anyone like to respond to that point?
I can kind of add to that. Basically, it's a great point. Like you may have a solution, even like if it's a solution, and people may have practiced in a different way. So it's very difficult. Change is quite difficult in general. So if people are used in any industries, in any government sector, if they're used to performing something in a specific way, it's quite difficult to change them. And it can be changed in terms of like their perception of risk, and it can be like in the way that they work and basically overcome the challenges, or it can also be about the trust and how much they trust the methodology, the approach that you take, and especially with the AI and the sort of black box understanding that has happened, that existed basically in the past. Gladly, with the launch of, let's say, all of these language models, people are more open to using AI because they see that they work, although we do not necessarily use the language models for our modeling purposes. But these are the three pillars of challenges that I think exist as well.
And before I lose this point, you had mentioned geospatial reasoning, the LLM. Is that publicly available at this time?
Not yet. Hopefully soon. But yeah, I mean, if you're interested, if anyone's interested, please reach out to us, and we'll be happy to accommodate that if possible.
I might lead that chart. I might do that as well.
Wonderful.
I did quite.
Thank you. Of course.
Is there any other questions from the audience here? Oh. Well, I actually have another question, and perhaps while people are chewing on any last ideas that they want to go over. I've been looking into the MedEWSA project and finding it to be really fascinating. And I noticed, as well as what you shared, Elena, is that there is a twinning project which examines the forest fire prediction in two different locations. Your twinning projects look at two different distinct locations. And for forest fire prediction, you have the twins being in Ethiopia and in Greece. And I found this like a really interesting approach to address disaster and like multi-hazard warning systems. So I'm curious if you can tell us a little bit more about what is the rationale for bringing together two different use cases, and kind of what are you unearthing or unlocking when you're looking at these, yeah, distinct situations, the similarities, and maybe some of the differences.
Yeah, thank you very much, Geneva. So actually, what we wanted to do is to bring, very different. I mean, in most cases, they're very different areas who have different capacities. They receive, they have different possibilities to react. The physical conditions, the climatic conditions are very different. However, they are affected by the same type of natural hazards. And how could we leverage what each one of those areas know, and how can they share their knowledge with their counterparts? That was the idea behind. So, for example, what you can see here, this is wildfires and extreme events. As you said exactly, on the one side is Athens, and then the other side it's Ethiopia with the forest fires. So what we want to do is to let the experience and the knowledge from the two different, very different case studies to fuse and actually prepare enhance capacity and let the people learn from the very different perspectives what would be the solution. I mean, this does not mean that the north is better than the south. Imagine, for example, if I take you a bit further down, we have, for example, for these heat waves and droughts and wildfires, the combination is Catalonia in Spain and Sweden. We do know that the Swedish are extremely advanced. They are very well organized, but we do know as well that the people in the Mediterranean, they're very well prepared when it comes to heat waves, droughts, and wildfires. So what we do is we let the one learn from the other. Bridging also very different types of data, looking at different drivers, as we're looking also in the climatic conditions behind this. We are, since we are very much interested in forecasting and looking into climate drivers that are leading to this type of events. So is this exchange, knowledge exchange, interaction, and capacity building for all these different types of all these twins. So we have, as said, the heat waves, droughts, and wildfires, Catalonia and Sweden. We have floods and landslides in Georgia and Slovakia. While we have coastal floods and storm surges, so actually floods that are influencing, that are impacting on the one side, Venice, the very well-known Aqua Alta of Venice, but also on the other side, the Alexandria, just next to the Nile Delta, with lately very frequent extreme events that led to very large storm surges and very big impacts around that urban area.
Great, that was fascinating. There's a question for Ali too, I think, in the chat that we'll move to, but I loved what you said about the shared capacity building, but also requiring a bit of a nimbleness and flexibility with different data sets. I think that's really critical for researchers, and how do you integrate different like multimodal data. Okay, Ali, the two questions in the chat for you. Are you using any remote sensing data for this? And what types of data? And how would you downscale the data to your current spatial resolution? I'm also very interested in that. And then the other question for you is, what extreme events are you working with besides wildfires? So please take it away.
So yeah, great questions. I'll try to be quick. So yeah, we basically for the fire forecasting thing, we use I think 5 different types of data. So climate, terrain, vegetation, human factors, and past fires. So in total, there's like tens or hundreds of different layers that go into our forecasting model. And among them, basically, the key factors for fire forecasting is included. So vegetation, or basically land cover, NDVI, anything related to the vegetation condition, drought condition, and things like that. And those are mostly coming from the satellite data, remote sensing data sets. Generally, around 100-meter or so in public data set, or 200-meter or so resolution for public data sets. And then for terrain variables like elevation, slope, or things like DTM and things that are quite influential for fire spread, at least. Those are the, I think, quite high resolution stuff that are, let's say, even 10-meter resolution or even less than that. Google has a ton of data sets. And then for climate, those are probably the coarsest resolution ones. Those are, let's say, usually you have 1 kilometer or even sub-kilometer data sets as well, but the frequency for update, because we want to have relatively operational things, those are also important for us as well. So usually it's 1 kilometer, 4 kilometer, things like that for the US, but for other regions, it may be different. How do we basically go from there? There's a lot of different downscaling approaches, for sure. Like we do downscale them. I mean, it's not the greatest for, let's say, some of the climate variables that we have, but for some other factors, we do not need to downscale, because it's basically, let's say, for human factors, it's distance to firefighting stations, something like that. So it's basically a single value, and these are available for different areas differently. So there's like a bit of data gap in some areas, but generally the consistency for climate and vegetation data, because it's coming from satellite data, exists there. And then the other question for modeling side, we basically have focused mostly on wildfire. We have looked at other things as well, but for now it's a small team and there's a ton of, let's say, different industries, different sectors. So we have focused on wildfire, but it's not necessarily just one tool. Like you don't have just one model that predicts everything. So we have a model that predicts hazard, and then we have something for explainability, which factors are influencing risk scores at each location. And it's basically looking at the top 10 drivers of fire and top 10 suppressor of fire risk. And then we have vulnerability model, we have, let's say, spread model. So there's a whole suite of models, and every time we talk to an insurer or reinsurer, they are interested in developing something else as well. So there's a whole lot of things. But for now, for the modeling side, it's mostly on wildfire. And but for the other tool that I mentioned, post-disaster imagery, image geolocalization, that one we take any sort of extreme event that has happened. So usually, like some of the challenges, tornadoes generate a lot of debris, and the computer vision models are a little bit susceptible to those debris and to identify the exact location. But we've had a ton of, let's say, great examples of extreme events completely filling up the area and changing the landscape, but still we have been able to geolocalize the event. I think on our website, we have a sample image that is basically the area is completely flooded. There's only 2 buildings standing out, and we are able to identify that. But yeah, that's sorry if I thought.
No,
Hopefully
it's
it was
great.
useful.
There's a very quick follow-up. Is there an optimal resolution? Is 1 kilometer enough? I mean, that's the million-dollar question I think we see.
Yeah, correct. I mean, I guess the scientists and also practitioners, they never say it's enough. So I guess the question is, how much does climate actually change, like location by location? So usually 1 kilometer is good enough, because like if you think about precipitation or, let's say, temperature, it does not change necessarily block over block. Yes, for sure, for, let's say, heat islands and things like that, definitely 1 kilometer is not that great. But usually 1 kilometer is very good for a lot of applications. And you can kind of assume that it does not change, or it kind of linearly changes between one location to the other. So you can kind of downscale it. But if you're focusing on, let's say, snow accumulation or things like that, 1 kilometer cannot be that great. Or if it's like a hugely homographic, orographic focused area, influenced area, then probably it's not the greatest resolution.
Yeah, things like landslides. Okay, excellent. So I'm going to give a really quick opportunity for last remarks. And before I do so, though, I've put in the chat that you can access the recordings as well as the literature and summary blogs that we're producing. We sort of pull the main takeaways from this, and it's been incredibly rich. And I love the threads we're pulling across from these panels. Also, this has been an excellent active chat. And so I'm going to put everything that was shared in this chat into the references on the website itself. So yes, please, and continue to follow LEAP for updates for future panel series like this. So we have, there's a question in the chat. Ali, perhaps you could spend to that, respond directly, but I just want in the last 2 minutes here, if you have a sentence from based on your work, I would love to know what you hope your research and projects can enable for the upcoming fire season. Just a sentence or two, something to uplift us as we launch into this season. Jorge, we can start with you, and then Jatan. I'd love to hear your thoughts.
Yes. Well, from my perspective and my work, I would say that we aim to improve the understanding of the heat waves and how the different drivers can be better used for predicting and attributing the different extreme events, not only heat waves.
Brilliant. Jatan, your hope.
It's tough to be hopeful given the current setup in the US. But I will say that what gives me hope is that it's an ENSO neutral phase, so it's not a El Nino or a La Nina, a strong one at that. So that is hopeful. The climate might help us, and from a modeling perspective, I think this is the signs indicate that we can probably avoid the worst.
Great,
That's the best hope I can.
ENSO neutral is hope. There we go. Ali, your wish for the weather.
I think it's the greatest time to be alive, honestly. Like the tools that we have, no other generation had access to, and the AI revolution, honestly, has been amazing. Like in many different industries, hopefully, it can do amazing upgrades and improvements in the climate forecasting space as well, and extreme events as well. So there are a lot of movements in weather forecasting, AI-driven weather forecasting, and climate forecasting, and also extreme event analysis. So it's a fascinating time for sure, in my opinion. Hopefully the industry and the users will also be able to keep up and be interested in using more and more of the AI-driven models and be able to basically leverage this. But yeah, I'm hopeful for sure. And the past few months in California, there has been a lot of rainfalls, so hopefully it won't be a very bad fire season in California. Yes, that's the other thing.
Fingers crossed. It's an important time for us folks who are passionate and interested in this topic. We have a lot of opportunity, but a lot of potential to apply our work. Elena, some last thoughts on your wish for MedEWSA and the work going forward.
Yeah, thank you so very much actually for the organization of the whole panel. It has been really great, first of all, and then what we're hoping that MedEWSA will be able to do is to enhance preparedness. So unlike California, Europe has been facing a very long drought, and the seasonal forecast is calling for a very hot summer coming up. So actually the preconditioning seems to be there. And what we hope to do is to advance with the impact, because for us, forest fires are the impact of preconditioning related to climate conditions, and not only, and to be able to provide the required information to the authorities so that they can prepare actually and deal with these challenging times. That would.
Great. Well, thank you all so much. This was such a fantastic conversation, and I am so excited to write up the output and share it with you all. And yeah, definitely, please check out all the literature that was shared. We'll link it. Stay tuned. We'd love to continue these series, but we will be signing off for the end of the academic year here at Columbia. And yes, I wish everyone bliss and rain and more ENSO neutral states to not drive too many extreme events in our world. So thank you all.
Thank you.